Welcome back to the Parent Effect. This is the exam series. So we're looking at doing a whole lot of tutorials that go through past papers question by question so that you can figure out how to complete each question. So today we are starting off with a 2022 paper from the May-June series, and we're specifically looking at paper 11. So AS Mathematics, Pure Mathematics 1. Let's get going. So we're going to start with, of course, question number 1, which I thought was a really nice question to start off with, completing the square. So hopefully, if you're having trouble with these sorts of questions, I do have a tutorial on completing the square. But basically, all we do is halve this number. We subtract that number squared. So 4 squared is 16, and you always subtract no matter what. Doesn't matter if it's positive or negative, you're going to subtract it. And then you drop the 11 down, and then we simply make it look prettier. Oops, -5. So that is all you have to do, and your marks are given to you by getting that number correct and that number correct. Moving on to question 2. It's really important that you guys notice that when it says hence, it means we're going to be using something from the above question, okay? So they're presuming that you're going to use something from the above to answer this one. So in this case, we're going to be using our completed square form. So if we just borrow that from above, so it was -4 squared -5. Notice that on this side, it is now equal to 1. So we're going to put equal to 1. And it wants us to find the exact solutions. Exact solutions means that it needs to be in surd form or in terms of pi. Surds meaning square roots, okay? So you're not going to give decimals, you're going to give the exact value. So working this out, we'll move the 5 over. So we get 6. And then at this point, we're going to be square rooting. And remember, at AS level, when we square root, we are doing the plus or minus square root of that. And lastly, just moving the 4 over so it becomes positive on that side. So stating for the examiner clearly our two solutions. So it's going to be 4 plus root 6, and x will also equal 4 minus root 6. And those are our final answers for that one. Right. Question 2. This one is looking at the arithmetic progression. So we will need to be referring to our formulas from our formula sheet. And the first thing I do is try and pull out the information I have and look at the formulas that I have on my formula sheet and try and come up with some ideas. So when I read through this, I see the 13th term. So in my mind, I'm thinking U13 is 12. So that equals 12. And then it also says the sum of the first term, so S30 is equal to -15. And then lastly, it says find the sum of the first 50. So they're wanting us to find the sum of the first 50 equals question mark. So once I've pulled that information out, I'm then going to look at my formula sheet. So you'll notice on your formula sheet that there is arithmetic progression section. And under arithmetic progressions, you've got two formulas. You've got UN is equal to A plus N minus 1D, and you also have SN, which is equal to half N 2A plus N minus 1D. There is another one that continues on over here. That one's not used very often, and we're not going to be using it for this particular question. So if I know that the 13th term is equal to 12, I'm going to be using this formula. So I'm going to be writing that the 13th term is 12. So this part is 12. I don't know A. I do know N, however. N is 12. So I'm going to go N minus 1. So I get 11D. Oh, sorry. I was thinking it was the 12th term. It's the 13th term. So 13 minus 1 is 12. So it's actually 12D here. And that's my first formula that I'm going to be using. And then with this next one, I know that the sum of 30 equals negative 15. So I know that this side is equaling negative 15. And really similar, the only thing that I do know is n. So I'm going to be putting 13, no, it's 30 here and 30 here. Okay, so it's going to be half of 30, which is 15. 2a, I don't know what a is. I do know that n is 30, so that's going to become 29, but I don't know d. And those are my two formulas. So when I have two equations and I have two unknowns, that's a really wonky rectangle, I'm going to be using simultaneous equations. Okay, so looking at the easiest way to do simultaneous equations, I'm probably going to continue on with this one. And I'm going to make A the subject. So I'm going to move the 12D onto that side. So this is what A equals. So I'm going to be using substitution. I'm then going to replace what A equals into the other formula. So we're going to continue with that minus 15. And we're going to say it equals 15. But instead of having A, we're going to put 12 minus 12D. And then the rest of it is still there. So now we've got one equation with one unknown, which means we can solve it. First thing I would do, we've got negative 15 on this side, so I'll divide by 15. So I've got negative 1. You could still expand it. In fact, I'm going to expand this bit here. And then just continuing on. So just tidying that up there, I've got 24 there. Negative 24 plus 29 is 5D. I can move that over. Negative 25 equals 20 equals 5D. So D is equal to negative 5. And then to find out what A is, we can now put this one back into our little equation that we had there. So 12 minus 12 lots of negative 5 should equal A. So A equals 72. Now, we haven't quite finished because we found D, we found A, but we actually had to find the sum of 50. So the sum of 50 terms would equal half of 50. That's 2 lots of A plus n minus 1, which is 49, times D, which was negative 5. And if we do all of that on our calculator, we'll get negative 2525. Right, looking at question 3. So they're asking us for the coefficient of x4. So just reminding you, the coefficient is the number in front of the term. So the number in front of x to the power 4. And the expansion, blah, 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 is a. And the coefficient of x squared and the expansion of blah, blah, blah is b. And they want us to find a and b. So they're wanting us to find the coefficient of x4 and the coefficient of x squared in these expansions. And of course, there is going to be a second part to this question because this is part A. So you can see I have just grabbed the formula from the formula sheet for this specific topic. And I know that there are formulas that help you find the coefficient of x4, and that's all lovely, but you know what? In exam, I tend to just start doing the full expansion and you pretty quickly work out which one's going to be the correct term because there's always such a beautiful pattern. So I'm just going to show you how I go about doing that. So in this particular situation, this is A and this is B. So if we were going to start expanding that, we would of course be doing 2x squared, and that would be all to the power of n. And the next one would be 5c1, and we would do 2x squared, all to the power of 5 minus 1, so 4. And then the b starts coming into play, so k squared over x. Notice that I always put them in brackets. Really big mistake is not putting those brackets in, and then you don't do 2 to the power of 5 and you get the wrong answer. So just be really mindful about putting everything in brackets. So if we start to look at the pattern already, this one is going to produce something to do with x to the power of 10, because 2 times 5 is 10. This one, I've got x to the 8 in this section. In this section, I've got it over x. So x to the power of 8 over x is going to be x to the 7. So if we're going to predict this, it's going down by 3 each time. So we know that the next one is going to be the correct one. Okay, so the next one in terms of our little formula sheet is this one here. So this is going to be the key one that we need to work out. So doing that one, it's going to be 5c2, a, which is 2x squared, is, see, I did the brackets wrong. 2x squared to the power of n minus 2. So 5 minus 2 is 3. B squared is k squared over x squared. Now, we need to work out what 5c2 is. So 5c2 is 10. Just to clarify, if you're trying to find c on your calculator, it is shift here. Whoops, shift the division button. So I can go 5, shift. Doesn't like my shift button at the moment. No. Shift C2. Okay, so that's going to give us 10. So it's just, on my one, it's above the division sign. It might be different on different brands, but that's the most common type of calculator, Casio. So 5C2 we've got is 10 times 2 to the power of 3, which is 8. X to the power of 2 to the power of 3 is 6. And I left off the squared for this, didn't I? So when we're doing this one, it should be k squared over x, and the whole thing is squared. See how mindful we have to be of our brackets, because otherwise we would get the completely wrong answer. So k squared squared is k to the power of 4, and x squared is, of course, x squared. So we can straight away see that x to the power of 6 over x to the power of 2 is going to give us the x to the power of 4 that we want, and the remaining 10 times 8 times k to the power of 4 is giving us the coefficient. So the answer that we're wanting for A is 80k to the power of 4. Okay, so that is our A. And doing the same sort of thing for B. So we're going to be expanding this guy up here, and we're wanting the coefficient of x squared. Now, because there is no x's in the second bit, it is going to be the one that has x squared on here. So that would be this one here. So it's going to be the one that would produce this one squared. Okay, but again, if you're not sure, you can always start expanding and just see the pattern, okay? So we are going to be doing 2kx minus 1 to the power of 4. We're just looking at that nc2 term, so it's going to be 4c2 times 2kx to the power of n minus 2, which is 2, and negative 1 to the power of 2. Remember, these things here should always add to that one, which is how I noticed that this one wasn't right, because they needed to add to 5 there. Okay, so let's work that out. So again, 4c2 is 6. 2 to the power of 2 is 4. K squared, x squared, and negative 1 squared, we get back to a positive 1. So we really just have B is 6 times 4, which is 24 k squared. Okay, remember, we don't need to include the x4 or the x squared, because they were only asking about the coefficient. Right, let's have a look and see what they want us to do with those. Given that a plus b equals 216, find the possible values of k. So we're going to be taking our answers from above. Of course, there would be follow through if you had got them wrong. So we had 80k to the power of 4 plus 24k squared, and that equals 216. Now, looking at this question, my hope would be that you would notice it to be a quadratic, a disguised quadratic. So if we make it equal 0, hopefully you can see that we can think of this as the x squared term and the x term and the coefficient, okay? So like a, b, and c. Before I do that, I am going to make the number slightly easier. So I'm just going to divide everything by 8. We get 10 k4 plus 3 k squared minus 27. So I'm going to let x equal k squared. So if x equals k squared, hopefully it makes sense that x squared will equal k4. So this equation will now become 10x squared plus 3x minus 27. Now at this point, you can just chuck it straight into your calculator. If you're learning how to use your calculator, you would be putting it into this one. You're choosing polynomial, you're choosing second degree, and you would literally just type it in. And you would get 1.5 and -9/5. Of course, not all of us have got a fancy calculator. If that's the case, you need to split the middle term into two things that add to 10 and multiply to -27. Sorry, add to 3 and multiply to -270, which is not the funnest numbers to think of, but they're 18 and 15. Once you've done that, you can split it up. 2x, 5x plus 9, 5x plus 9 again. So your two factors are 2x minus 3 and 5x plus 9, which of course give you those two answers that the calculator gave us straight away. Now, that's what x is, but we actually want to know what k is. So if we switch it back to k, we need to square root it. Now we cannot square root a negative number, so this one has no solutions. I would always write that to tell the examiner that you've considered it as an option. And this one is going to equal plus or minus √3/2. You can write them in decimals if you would like to. Question 4. This is a trig identity. So remember, with trig identities, we have to start with one side. We're going to start with the left-hand side. So we tell the examiner that left-hand side is equal to. And I have kind of two tips that I use mainly with these. Firstly is I generally like to make everything sine and cosine. And the second thing I look for are common denominators. So that's what we're going to do. We're going to make a common denominator. The common denominator is going to be these two times together. And in order to do that, we're going to have to multiply that one up and that one up. So we're going to end up with sine cubed theta all times by 1 plus sine theta minus sine squared theta times sine theta minus 1. Oh, so just expanding that numerator. Don't know why I did it in that order. Negative sine squared times -1 is going to become positive, so just be really careful with your positives and negatives. These cancel out, which is lovely, and I haven't done anything to the bottom so far. So the next line, I am going to factorize sine squared out of the top. And on the bottom, I am going to now expand it. Sine theta times 1 plus sine theta times sine theta minus 1 times 1 minus 1 times sine theta. So those cancel out. What you'll notice on the bottom is that that is the difference of two squares. So remembering like x squared minus 9 is the difference of two squares, it would become x plus 3 and x minus 3. So as long as each thing's a square, I can square root each one. actually. I'm not going to want to do that because I'm wanting to cancel it out with the top. So I'm just going to manipulate that bottom slightly. And I'm just going to factorize -1 out because I'm wanting to use the fact that I can make it cos squared. Leave the top the same. So hopefully you guys are okay with the fact that sine squared is cos squared equals 1. So therefore cos squared is equal to 1 minus sine squared. And that's what I'm going to do on the bottom here. I'm keeping the top the same at the moment. And the bottom is -1 times cos squared. So sine squared over cos squared is tan squared. Oops, don't want to use that pen. Still over -1. Let's just check what we're trying to make it equal, because it's always really good to keep notice of that. So we're trying to make it negative tan squared theta 1 plus sine squared theta. So we're essentially there. Dividing by -1 is the same as timesing by -1. Now, I know these questions can be really difficult when you're in the exam. You'll notice that, you know, I originally thought that I could completed the square here, but then I looked at the top and went, actually, that's still squared. So you're always just thinking about different options. Remember that this is worth 4 marks, and a lot of those marks are allocated to method marks, not to being able to fully prove it. Okay, so every time you do a correct step and use a new identity correctly, you're going to get some method marks. Right, question B. Using that word hence again, which means we need to use our answer from previously. And just be really careful because it looks so similar to what's going on the right-hand side. So this we just proved to be negative tan squared theta 1 plus sine squared theta. And on this side, we're making it equal tan squared theta 1 minus sine squared theta. So I'm just going to move them all to the same side first of all. And I'm going to expand it at the same time. So tan squared times 1. And it's going to become minus sine squared theta, tan squared theta. Moving this one over, that negative tan squared is going to become positive tan squared plus tan squared theta, sine squared theta. So you'll notice that this one and this one cancel out. So we have 2 tan squared theta. We can divide by 2. And we can inverse tan, so theta is just going to equal, everywhere that it equals 0 is going to be 0 pi and 2 pi. Question 5 is a circular meta question. So first of all, I like to kind of come up with a plan of how to attack the problem, and it helps examiners see what you're actually doing if you do that anyway. So we know that this angle is actually 1/6 of pi, and we've been asked to find the exact area of BCD, so this section here. So my strategy is going to take that whole sector and I'm going to minus the triangle, and that's going to leave me with the bit left over. Just reminding you, when they say exact area, that means it has to be in terms of pi and square roots and things, okay? So they do not want any decimals. So I'm going to tell the examiner what I'm doing by first of all saying we're working out the area of the sector and that we're going to minus the area of the triangle. And that helps examiners see where to look for the method marks. So with the first one, area of the sector, we know the formula for that is half r squared theta, and that is on your formula sheet. And there's a couple of formulas you could use for the triangle. You can use half base times height. I'm going to be using half AB sine C, which is not on your formula sheet, but it's just so useful to remember. The main thing with this one, that the formula only works if the C
is between the A and B. Okay, so it works when you have the angle between the two sides you're looking for. Okay, so a good formula to know for circular measure. Okay, so doing the area of the sector first, we have half r squared, and the only thing we have to substitute in there is what theta is, which in this case is 1/6 pi. And then we're going to subtract the area of the triangle. So to do the area of the triangle, we're going to do half A times B. So in this case, I don't know AD, so I'm just going to tell the examiner that I would like to times by AD, then times by this side, which is R, and then times by sine of the angle. Okay, so I've now discovered that I don't have all the information I need, so I'm going to be trying to find AD. Now, luckily, AD is part of a right angle triangle. So again, I'm going to tell them what I'm doing. So if we just think about this triangle here for a second, and we're doing it in terms of theta, if we're looking at AD, this one is going to be our adjacent side, and this one's going to be our hypotenuse. So in terms of our correct trig ratio, we're going to be using cosine. So cosine of the angle is going to equal AD over R. So if we just rearrange that, we can quite easily find AD is just R times that. Now, at this point, I'm going to grab my calculator and I'm going to put that information in. So when we use our calculator, make sure you're on radians, but sine of 1/6 pi, this one here is going to equal a half, and cos of 1/6 pi is going to equal √3 over 2. So I'm now going to put all of that back into my original formula. Tidying this little one up here first, a half times 1/6 is going to be 1/12. And then I'm minusing, so I've got a half. I'm timesing by AD, which in this case is going to be √3 over 2 lots of R. And then I'm also timesing by R again. And then I'm timesing by a half. So just simplifying that all out, and you're going to get 1/8. You put √3 over 8 R squared. And that is going to be your final answer. Right, question B. So this time we have been given some different information, and we're going to have to use that instead of theta to help us find the exact perimeter. So again, using the word exact, meaning we need to find it in terms of pi or give the square roots as exact square roots. So what they're wanting us to find is the perimeter of BCD. So they want us to find this section here. So again, plan your strategy. So we need to find we need to have B, C, so this section here. We need to have BD, and we need to have DC. So in terms of those three things, we already have some of it. So BD we already have is √3 over 2R. So that's that bit done. And then in terms of finding BC, well, that's just going to come from R theta. So I'm going to write that down. Again, a formula that's provided for you on the formula sheet. And then DC, well, my strategy for DC is to do R, which is all of this, minus AD. So in order to do this, we've got a little bit of information we need to work out. We need to find out what AD is, and we need to know what theta is. So first of all, let's find out what theta is. Again, telling the examiner what we're trying to do. So this time we know that BD, which is this bit here, √3 over 2R, is √3 over 2R. And then we need to use our trig ratios to find out what theta is. So This is opposite the angle and this is hypotenuse. So we've got opposite and hypotenuse, so we're going to be using sine. So sine of theta is equal to opposite divided by hypotenuse. So the r's cancel out and we get √3/2. So if we just inverse sine that, again, make sure you're in radians, you're going to find out that theta is exactly 1/3 pi. So that's going to help us for a couple of things. It's going to help us put the information here, but it's also going to help us find AD. So if you recall from above, we know that AD is R times cos of the angle. So we can then go, right, well, actually AD is R cos of the angle, and in this case, the angle has become 1/3 pi. So if you chucked cos 1/3 pi in the calculator, you would in fact get a half. So putting all that information that we know back into the formula. So starting here, r times theta, so that's r times 1/3 pi. We're already given √3/2r. And then we've got r minus half of r. Just to make that slightly prettier, let's put the r's at the end. And then 1 minus a half is, of course, a half. But really, at this point, you could leave it like that. If you wanted to, you could factorize the r out as well, but that will give you the full 4 marks. We have a function, it's defined as blah, 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 for x is greater than 2. And the very first question they ask us to do is find the expression for what? So you do need to know the notation. So this is an inverse. Okay, just be mindful that f dash x, that's differentiation. Okay, and with the -1, that's our inverse. So we're trying to find the inverse. This should have been something that you learned in your GCSEs as well, but they're generally a little bit more complicated when we get to AS level. So the technique that I use, and I know a lot of teachers teach with, is by switching your x's and your y's around. So instead of having f of x, or what we think of as y there, we will change that to x. And we'll change the other two to y. And then our aim is to try and make the new y the subject. So to do that, I am going to multiply up. And you'll notice straight away that it's looking a little bit tricky because there's more than one y. Whenever you have more than one item that needs to be made the subject of, you need to be thinking about either completing the square or factorizing. So what I'm going to do here is I'm going to expand that left-hand bracket out. And I'm going to bring over the y squared. Oops, or x instead of equals. And then I'm going to be factorizing the y squareds out. So I'm going to move the y squared so that they're on the same side and everything else is on the other side. I've just noticed that I've written this one down wrong, which is going to really stuff everything up. Minus, that was minus, so that moved over, so it became plus. So I'm just going to keep our xy squared here and our minus y squared here. And then these two other ones are going to move onto the other side. And at this point, I can factorize the y squared out. And I've got -4x minus 4, and then just dividing that over. Now, if you're like Cambridge and you hate negatives, you could divide the top and bottom by -1. So you're dividing by -1 over -1, which essentially makes no difference. It just switches the things around on the bottom. So at this point, we want to be square rooting, and I know that we're always told we need a plus or minus square root, but this is where the domain comes in handy. Okay, so because they're looking at the right-hand side of this function, you want to be only doing the positive square root. Okay, if it was looking at the left-hand side, so less than 2, then we'd be doing the positive. So we're going to, that's not going to be a useful pen. So we're going to square root all of that. And that is going to be your answer. And if you did leave the plus or minus in, you would have lost 1 mark. So moving on to our next question. Show that you can write that lovely expression on the left as the one on the right. And then we're going to work out the range. So the first thing is reasonably easy to do. When we have 1 minus 8 over x squared plus 4, our aim is to make a common denominator. And so hopefully it makes sense that the common denominator is going to be x squared plus 4. And if you think of that as 1 over 1, you're really just going to be cross multiplying. So multiplying that up is going to be x squared plus 4. And then the 8's still there. And then you just tie it up and it just drops out straight away. Okay, so we've showed that. And then it says, and hence state the range of f. So you'll remember from the first part of the question that the domain of the function was x is greater than 2. So we need to investigate what happens when x is greater than 2. So let's look at what happens when x is actually equal to 2. So if I put 1 minus 8 and I put 2 squared here, you will notice that I get 1 minus 1. So I get 0. Okay, so I know that one of the limits of the range is going to be 0, but I also need to check that there isn't something else going on. So if you think of the domain as x is greater than 2, let's also consider what happens when x approaches infinity, because obviously if x is greater than 2, it's going to be 2 all the way up to infinity. So when x approaches infinity, so let's say infinity squared plus 4 is still going to be infinity. So what we've got here in this little situation here is we have 8 divided by the biggest number in the universe. So if you want to divide something, any number, by a really, 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 really big number, it's going to approach 0. So this whole section is approaching 0, which means that as x approaches infinity, our whole function is going to be approaching 1. Okay, so that means we actually have 2 limits here. So we're going to say that it's our function, or y, is going to be less than 1. It never quite reaches 1. And it's going to be greater than 0. It never quite reaches 0 because it wasn't x is greater than or equal to 2. Okay, it never quite equal to 2. And those are your other 2 marks. Right, the final question. Explain why the composite function ff cannot be formed. Okay, one of the key things we need to remember with domain range is that they restrict what we're allowed to put in and what can come out of a function. So when we look at the original function and it said that x had to be greater than 2, and then we know that what comes out of that function is numbers between 0 and 1, we can see that these numbers here are not able to be put back into the function again. So basically we say the output or the range of f does not include the domain or the input of f. Something along those lines, okay? Just something to tell the examiner that you understand that the outputs that you're getting from the first time you put it in are not going to be able to be put back. Question number 7. We are looking at where 2 functions or graphs intersect. You'll see they actually use the word intersect here. And as soon as you see the word intersect, I want you to be thinking about simultaneous equations. Okay, so we're wanting to find out where both of those equations happen to equal the same points. So with these ones, they're already y equals, so you can just set them equal to each other. So we're trying to find the 2 points where they simultaneously are at the same points. So half x plus 1 is equal to 3x minus 2. Now that's to the power of a half. I think it's going to be easier for me mentally to put square root because then I can intuitively see that I should square it. So because we've got a square root on one side, if we're trying to solve this, the only way forward is to square both sides. So if I square this side, and then this side's just going to become 3x minus 2. So squaring the left-hand side, just take it slowly. Remember, it is going to be 3 terms. So your first term is going to be half x times half x, so quarter x squared. And then your inner and your outer are going to both be half x. So half x plus half x is just x. And then your last is going to be 1 times 1, which is 1. Just take those things slowly in an exam. It's really easy to make a mistake. Now, at this point, I'm going to find it easier just to times everything by 4, simply because I have a quarter x squared. So x squared plus 4x plus 4. Remember to do the same thing to both sides. And then just making this pretty because it should start to look like a quadratic, which we're expecting because there are 2 points of intersection. So 4x minus 12x is minus 8x, and 4 plus 8 is 12. And then at this point we can factorize. So we're thinking of 2 things that add to negative 8 and multiply to 12. Cool, so we have x equals 6 and we have x equals 2. Putting them into either one of those equations, I'm going to use half x plus 1. So halving x is 3 plus 1 gives me 4. Halving x is 1 plus 1 is 2. So those are my 2 points of intersection. Right, with the next question, we are asked to find the area between those 2 curves. So when we're trying to find the area, we are integrating, and we need to integrate between the 2 points of intersection. The points of intersection need to be in terms of x. So we know that the x points were 6 and 2, and then you do the top graph minus the bottom graph. So if we're going to look at the top graph, that was the curved one, which is our 3x minus 2 to the power of a half, and then we're minusing our bottom graph. So I'm actually going to expand that out. Okay, so essentially I'm subtracting a half x minus 1, which is, sorry, a half x plus 1, which means when I expand it, I get that. So just be really careful when you're doing that. And technically I'm doing it with respect to x. Right, now we have to integrate it. So at this point, we're looking at this one and we're thinking, oh, reverse chain rule. So when I do the reverse chain rule, I write down all my gobbledygook and I always raise the power to 1 more. Okay, so add 1 to the power. So I get 3/2 or 1.5. And then I think to myself, right, I'm going to divide by the new power and I'm going to divide by the derivative of the inside. Okay, so both the 3/2 and the 3 are going to be going on the bottom of that. Moving on to the next one, add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. And all of that is happening between 6 and 2. So if we tidy this up, if you go 1 divided by 1.5 times 3 on the calculator, you will get 2/9. And then we still have all of that. Minus a quarter x squared minus x, and that's all going to be done between 6 and 2. So to work that out, you're just going to substitute 6 in. So we're going to get 16 in here. It's going to put 1.5, it's easier. 6 squared is 36. And then we're going to do the same thing, but substitute 2 in. 6 minus 2 is 4. 2 squared is 4. And a quarter times 4 is 1, and then minus 2. And we chuck that all in our calculator, and we will get 1. We're looking at a curve, sin x, that has been transformed. So obviously transformation started in 2020. They changed the syllabus, and They're really something that you need to be working on if you want to do well in the AS exam. So hopefully you have some idea about what each of these numbers does to a trig graph. We're just going to go quickly through them. So the 4 in front is your amplitude, so it changes the height. So a traditional sine graph goes up to 1 and down to -1. And that takes a full 360 degrees to do that. So when they change the amplitude to 4, it's going to simply go up to 4, but also down to -4. Okay, so it's just stretching it vertically. Now, both of these are happening on the x-axis. So if we start with the 30, that is going to be a translation left or right. Now, because it's in brackets, it's always going to be the opposite. So -30 is actually going to be a shift to the right of 30 degrees. And then the half x is a change in the frequency. So the normal one does 1 full cycle in 360. If it was 2x, it would do 2 full ones in 360. But this half x is actually going to slow it down. So it's actually only going to be able to do the top bit, if you like, within the 360 degrees. Now, in terms of getting the order right, the amplitude can happen at any time. We can stretch it by 4 and it's not going to affect the other things going on. But because the frequency is slowing down and making this wider, we need to make sure we get the order of those correct. So the easiest thing I think to do is to start with the translation. So the first thing I'm going to say that we're doing is that we're translating to the right 30 degrees. Okay, you need to mention left or right, and you need to mention translation. It is not good enough to write transformation. These are all transformations. We need to specifically use the language. Once we've translated it to the right, we can then tell the examiner that we're going to do the horizontal stretch. So we call that a stretch of 2 in the x direction or horizontal. Okay, if we were going to do these the other way round, and so we could have number 1 would be the stretch of 2, that would mean that our next one would have to be a translation of 60 degrees, right? Okay, and that's why I think it's better to just do the stretch, do the translation first. Lastly, or at any point, we can put in the stretch vertically by a scale factor of 4. So the keywords are stretch and translation. You need to use vertically or y direction in those as well. And that is the whole of that question. Right, we're then going to be using that equation to do a little bit of solving. So with this one, it's easiest just to get sine all by itself. So we're going to take 2√2 and we're going to divide it by 4. And then we're going to inverse sine that. So inverse sine of 2√2 divided by 4 is going to give us 45. So we now know that half x minus 30 is equal to 45. And that's okay for a GCSE level, but we're now at AS, so we need to know that there are more than one answer. So if we just think of the normal sine graph, we know that if it's going to be an answer at 45 degrees, there's also going to be an answer here. So that second answer is going to be 180 minus 45, simply because of the symmetry of the graph. So we're also going to have an answer of 135. I always get all my solutions when I inverse the sine, cos, or tan. Grab your solutions then, and then the rest of it will just work itself out. So we can now add 30 to both of them. And then lastly, we can times by 2. And those are our solutions. Right, so this time we are looking at a circle. So we're trying to find the center and the radius. The best thing to do here is to just put the x's and y's together to begin with, and chuck any numbers onto the other side. And then we kind of complete the square but for each section. So what we're going to do for this one is we're going to do x plus 3. So we're halving that number. And then we subtract that number squared. We do the same thing again. So we halve this number, subtract that number squared. All the numbers can then pop onto the other side. So we get 36. So you can see that the center is going to be at -3, 1, and that the radius is going to be 6, because remember this represents r squared, and these are in brackets, so we change the sign. So from that, we hopefully can find the lowest point of the circle. So just drawing a little picture of our circle. Our center is at -3, 1, and we know that this distance here is 6. So if we look at the y value, it's 1. If we drop it down by 6, it's going to give us the lowest point. So the lowest point is going to be -3, -5. And we are done. All right, the next part of this question is then taking that same equation, but this time we're wanting to know the set of values for which the line intersects the circle. So intersects a circle at 2 distinct points. Hopefully you're thinking, oh, I think this has got something to do with the b squared minus 4ac, and that would have to be greater than 0 for that point. When we see intersects, that means we should be doing simultaneous equations. So 6 marks, we know it's going to be a bit of work. I'm going to start with the equation I had that I'd completed the square of, because I find that a little bit easier to work with. But instead of putting y here, I'm going to replace it with what y equals from the other equation. And just before I expand it, I'm just going to tidy it up. So here I've got kx minus 6. Right, I have 2 squared brackets that I need to expand. So this one is going to be x squared plus 6x plus 9. And then this one's getting pretty tricky. So we're going to square kx. That's going to be k squared x squared. We're going to be timesing 6 by kx a couple of times. And then lastly, we're going to be squaring 6. So we get 36. Straight away, I can chuck the 36s over onto that side. And at this point, because I'm heading towards a b squared minus 4ac style question, I want to be collecting my x squareds together. So I've got x squared and I've got kx squared, k squared, x squared. I'm going to collect my x's together. So I've got 6x from here and then minus 6kx from there. Oh, actually 12 of them, because I should collect those two together. And then lastly, I have a 9. So in terms of working out what my a, b's and c's are, if I just factorize x squared out, I have 1 plus k squared. That's going to be my a. If I take my x out, I've got 6 minus 12k, and that is going to be my b. And lastly, c is the only one that's nice. It's just 9. So we're then going to substitute that into b squared minus 4ac. So b squared is going to be 6 minus 12k squared minus 4 lots of a times c. And we're saying that b squared minus 4ac should be greater than 0 in order for it to have 2 distinct points. Expanding this one, we're going to get 36 minus 144k squared, 144k, plus 144k squared. With this one, we've got minus 4 and 9, so we've got minus 36 and minus 36k squared. So again, the 36 cancel out. We then have 108k squared minus 144k. So just dividing them both by 108 and by k, we end up with k minus 4/3 is greater than 0. So that gives us intercepts at 0 and 4/3, and just working out what direction those will be. If we drew a quick sketch of this, of what's going on here, we know it intercepts at 0 and at 4/3, and it's asking us where is it greater than 0. So that's going to be this section and this section. So when k is less than 0 and when k is greater than 4/3. And we have managed to do that the equation of curve is such that its second derivative is equal to all of that. And they also tell us that there is a stationary point at -1 9/2. So starting off reasonably easy, determine the nature of the stationary point. So we can find the nature of a stationary point by putting it into this equation. Okay, so the second derivative always tells us the nature of the turning point. So all we're going to do is put x equals -1 into that. And if you chuck that in the calculator, you get 10. And that means that it is a minimum. So remember, if it is a number greater than 0, it's a minimum. And if it's less than 0, it is a maximum. Finding the equation of the curve. So 5 marks, a little bit more difficult. So in order to find the equation of the curve, we need to integrate twice because it's being differentiated twice. So first of all, we're going to find dy by dx by integrating what they gave us before. Now, instead of writing x cubed on the bottom there, I'm going to bring it up to the top and make it -3, so it's easier for me to integrate. So integrating there, I'm going to add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, and then I'm also going to get a plus c. Now I need to find c, and I'm going to use that by looking at the fact that a stationary point occurs at this point. So we know that at x equals -1, dy by dx should equal 0. So we're going to substitute those things in. And if we do that, we find out that c is 0. So the next part is to integrate it again. So y will now equal the integral of 2x cubed plus 2x to the -2. So same thing, we're going to add 1 to the power, divide by the new power, add 1 to the power, divide by the new power. And then we still have a plus c, but we now know that if we just go back up to the top, there is a stationary point at -1 9/2. So we know that there is a point. This is x, this is y. So if we put y as 9/2 and put -1 in, that will help us find this other constant of integration. So as we put all that stuff in there, we get 4.5 on that side. We get 2.5 on this side. So we find out that c is in fact 2, which means that our equation, just making sure we write it for the examiner, is that. Right, show that the curve has no other stationary points. So we know that stationary points occur when the derivative equals 0. So we're going to take the derivative, which was 2x cubed plus 2x to the -2, and we're going to set it equal to 0, and we're going to solve. So for me, solving, it makes more sense to put that on the bottom. So I'm going to times everything by x squared. And then I'm going to move that 2 over. I'm going to divide by 2. And lastly, I am going to fifth root. When I fifth root it, I get that x is -1, which was the only stationary point we were told about, which shows that there is just the 1. Lastly, it is a rate of change. So when I'm doing these ones, I like to write down the information that I'm given. So a y coordinate is increasing at a rate of 5. That's telling me that dy by dt is equal to 5. And I want to find the rate of increase of the x coordinate. So the thing I'm trying to find is dx by dt. So I write dx by dt and I put a question mark. So if I want to know dx by dt, that means I need to have dx on the top and I need to have dt on the bottom, and then I need to have another variable that's going to cancel out. So clearly the other variable is going to be y. This is good. I have this one straight away. That's no problem at all. dx by dy, I don't really have that one, but I do have dy by dx. So let's just look at dy by dx at x equals 1, because they said to find it when x equals 1. So substituting into that, we get, so we have this lovely equation. So when I put 1 into that, I get 4. So I can now substitute into my formula. So I want dx by dy, so I'm going to flip it over, 1/4 times in by 5, and that gives me the rate that it is changing, which is 5/4. And we have completed one whole paper.